So what are they calling? They're not calling.
Miss Blackman, can we have Thomas Sam card to check out, please?
Yes, ma'am.
Thanks.
Thomas, just make sure you watch the video, baby, okay? All right, look, guys, they're not calling it X. What are they calling it here? They're calling it T. Right here, it says T, okay? And they're not calling it Y, they're calling it H of T, right? All right, so part A, where it says H of T equals 4, what can we say? Well, instead of H of T equals 4, we can say Y equals 4, right? And there's two things that you can do. You can either look at your graph, or you can look at the table that they gave you about how are you. Bye, Thomas. Have a great weekend, dear. Now that I got my words out. There we go. So the table's a little bit easier to look at. Which ones have an H of T of 4? 2 and 7. There you go. So we got 2 and 7. That was easy enough. This is actually a really easy problem. It just kind of looks scary. All right, so we got H of 3. 3 is in the place of what? X. But in this time, they're calling it T, right? So when X is 3, or T is 3, what is H of T? 5. That makes sense to everybody? Y'all okay? All right, now, what are the coordinates of the point where H of T has an absolute maximum? We just learned this yesterday.
6.
Coordinates.
5, 6.
5, 6. Very good. All right. And then on what intervals of H of T is it increasing? So you got to remember intervals. You remember the parentheses and the brackets stuff that we've done before? Remember all that?
We're going to put...
Increasing means it's going up. So I need the X values of where it's going up.
Wait, would you start at 1?
You would start at 1. Does 1 get a parentheses or a bracket? It gets a parentheses. It gets a parentheses. Yep. Yes, ma'am. It is open. All right. Where does that continue on to? 3. And does that 3 get a parentheses or a bracket? Okay. All right. Anywhere else it is increasing?
From 3 to 4.
Now, since these two are right there next to each other on the same point, I'm going to use this notation called a U. That means union. That means I'm merging the two together since they're right there. And then does this 3 get a parentheses or a bracket? Parentheses. And where does it go to until it stops? Remember the roller coaster we talked about yesterday? 5. There you go. In parentheses or bracket? Bracket. Very good. All right. Then it says, where is it decreasing? Yes. -7 to positive 1, right? And those do get brackets. Very good. Whoever said that. Very good. All right. Now, I'm not going to use the U on this one because they're not right on top of each other like the other ones, because this one's right on top, but that's not decreasing. That is increasing, right? So I'm not going to use the U. I'm going to say and. Where else is it decreasing? 5 to 9. Do they get parentheses or brackets? Bracket. There you go. That was really easy math workshop, right? Everybody good? No, it just looks really scary. All right, so here's what we're going to do now. We are going to do 4 ACT problems. They are on the back of the ACT sheet that we've been doing. It's on the back. So what 4 problems are we doing? Yeah, and they are not hard at all. And we are going to save our perfect cubes until Monday. What, Sebastian?
Never mind, I wasn't here.
You've had this one for a long, long time.
Yeah. He was asking never went over the other ones, but I wasn't here one of the days you called me over them.
And you didn't do what?
Look at the video.
Okay, so we're doing 19 through 22, which means how many problems is that? 4, which means, I know. And we talked, and I said next time in November, and we figured out which ones we're doing, so that way we don't do the same ones. But we need to finish this one for everybody else that didn't go. So we have 4 problems, so we have 4 minutes. Do not start yet. Do not cheat, because you don't get to start early on the ACT. Anybody need a second? All right, 3, 2, One, go. 19 through 22. 19 through 22. Seconds. Here we go. All right, number 19. There's two different ways you can do number 19. The easiest way, though, well, is to find the area of the whole square and then take out this little square, right? What's the area of the whole square? 99. 99. How do you find that?
9 times 11.
There you go. The base is 11 times your height is 9. Which is 99. Does that make sense to everybody? Mm-hmm. Okay. And then you can just find this little piece, which if the whole piece is 11 and this piece is 6, how much is this one? 5. And if the whole piece is 9 and this piece is 5, okay, so that's 20. Subtract them and you get 79. Okay. Or the other way to do it is to cut them all in boxes And then this would be 5 times 5 is 25. This would be 6 times 5, which would be 30. And this would be 6 times 4, which is 24. Add them all together, and you would still get 79. Just kind of depends on which one you see. Are y'all okay? All right. What about number 20? Number 20. Start with the question. Just the question. What's the question ask you? On a curfew issue. So here's curfew. Here's no. What number is that? 12 out of how many? 60. Which is?
0.2.
Okay. That's 20%.
Multiplied by 1200.
There you go. And you get?
240.
Cross multiply will get you the same answer. Okay. Times that by 1200 and you get how much? 240, which is F. Y'all okay so far? All right. What about 20? 21 should have been so easy. Oh my gosh. 21 should have been so easy. What do you do?
Just plug it in.
And don't you dare waste time writing it down on your piece of paper, because you have wasted about 5 seconds. If you waste 5 seconds for each problem, what's 5 times 60?
300 seconds. 300 seconds.
A bunch, right? And how many minutes is that?
5.
Like 3 minutes, right? You
That's
wasted
5.
5 minutes. So you wasted 5 minutes on each question by wasting 5 seconds on each question. Or you wasted 5 minutes altogether by wasting 5 seconds on each question. Okay? So do not write that down. Plug it straight into your calculator. What was it? 3
Negative.
times negative 5?
3.
Yeah, minus.
And then
4 times 6.
Okay? Straight in, you get your answer. You've gotten this question in a total of 5 seconds, saving yourself 55 seconds for another question that you need more time on. So you should have gotten 39, which was A. Y'all okay?
ooh, I messed up.
You messed up?
I did negative 4 times 6.
Uh-oh. All right, can I scroll it? Nope. All right, here we go. Last one. Last one. So when you multiply two bases, what do you do to the exponents? You add them. When you divide two bases, what do? You subtract. And when we have something like 22 where we have one base, which is, there's only 2 operations left. Multiply, right? So what's 2 times u? 2u, right? Same thing. Since they have the same base, then you can say their exponents are the same. So 2u is equal to 12, so u is equal to 6. Same thing on this one. V times 2 is 2v. They have the same base, so you can say, yep. And v equals 4. What's it want you to do? And you get 10. Y'all okay? Good? All right, here we go. We are going to go over your homework from last night, quote unquote homework, right? Quote unquote, because I'm not taking it up. We just needed to do it before. What, baby? We're going to do domain and range together, yes. Yes, we're really going to do all of them together to make sure we're all on the same page. Wait. Number 3. There it is. There it is. Okay, number 3. What'd you get as your y-intercept? 5. What did you get as your axis of symmetry?
2.
X equals 2. Okay. And your vertex? 2 negative 3?
Yeah.
All right. Y'all okay so far? All right. And then you should have gotten a graph that looks something along the lines of that guy right here. Did y'all get that? I know that's probably crooked, but oh well. Are you okay with that?
That's really throwing me off.
What's really throwing you off?
The writing, like,
What wording?
it's on top of the words. Words on top of the words.
Oh, over here? That's fine. Just look at the graph. All right. Then, what did it want you to find? The domain and range? Okay. So domain is always what per parabola? All real numbers. What about the range? -3 to infinity with a bracket around -3 and a parentheses around infinity. Y'all okay? Okay? You shouldn't even ever need the graph. All you need to know is that it's a minimum or a maximum and where the vertex is, and you can find the domain and range from there. Is that all it wanted? Oh, min or maximum. Is it a min or max? Min. And what is that point? It will always be what? Your vertex. There you go. There you go. All right, what about number 4? Right off the bat, it's a maximum because you know it's going to be upside down, right? And what is that point always? Your vertex, right? Okay, so you need to do x equals negative b over 2a. But your b is your linear term, right? And you do not have a linear term, which is the x term. So it is 0. When you divide 0 by anything, you still get 0. When you plug 0 in, what would you get? So that means your maximum or your vertex is the same as your what? Maximum? The maximum? The y-intercept. Your maximum or your vertex, in this case, would be the same as your y-intercept. Okay? What else did it say? Domain and range, okay? All you need is this kind of picture and this. That's all you need. Okay, so what is your domain? Every time. And your range? Negative infinity to negative 12, right? Yeah. There you go. Y'all okay? Oh, fix it. We'll fix it then. All right, what about...
Why is 12 with 0?
Because when I did my axis symmetry formulas, there is no b, there is no x value.
So you just put 12 in there?
So you would put 0 there.
I got the 0, but where did you
Okay, when you plug in 0, 0 squared minus 12 is still negative 12. Yep. That's why we were saying it was the same as your y-intercept. All right. What about number 5? Max or min?
Minimum.
Minimum?
Mm-hmm.
Okay. What's your axis of symmetry?
3 negative 25.
3? Positive 24 over 8 is 3. Very good. 3. And when you plugged it in, what would you get?
Negative 25.
Did you even need to plug in 3? Did you really have to plug in 3? Where could you gone? Plugged into the calculator and found 3 where? In the table, and it will automatically give you negative 25 there. Y'all okay? Same thing. Either one works. Okay? Calculator is a little bit faster, especially if you're on the ACT. Domain and range? There you go. Wait, this is a minimum, so that'd be negative 25 to infinity. Very good. Good, good, good. Y'all okay? Any issues? You're going to have a checkpoint on Monday. I know it says checkpoint today, but I forgot we had a short class. So, all right. So the next set of directions are for the next page because I couldn't fit them all in the same thing. Okay. So what did the next set of directions tell us to do?
Explore with a graphing calculator.
There you go. Why do you think that we're going to need to use a graphing calculator?
Because we're going to graph.
Yeah, we are going to graph.
They're hard.
They're not harder, but they have really crazy decimals. Okay, they have really crazy decimals. So on your test, it will say, use a graphing calculator. And when you see those words, guys, that say use a graphing calculator, you better use your graphing calculator because it's going to be some crazy decimals. Get it good? All right, here we go. Let's go to page 3.
Use the graphing calculator.
It's the same questions, right? Just about. Same questions. Y'all with me? All right. So, number 1, what do you think we should do first with that function, negative x squared minus 3x plus 4? Well, it didn't ask me for that. Vertex? It asked me for the vertex, but what do I need to do first? How do I do that? Okay, before I even do that, go back to the directions. What did it say?
It said, identify the vertex.
In the directions, Bella, what does it tell us? Guys, what did I just tell you have to do?
Use the graphing calculator.
So where should we go? Thank you. Oh my gosh, that was like pulling teeth. All right, here we go. y equals,
Okay, yeah, sure.
and what we're going to type in? What was it? I don't remember what it was.
Negative x squared
Okay.
minus 3x
Yeah.
plus 4.
Beautiful. And then let's hit graph. Oh wait, hold on. Mine's messed up. Mine's messed up. Hold on.
You just went to a window, Misty.
I know. I gotta change that.
Oh.
All right. I had to fix something. We're gonna learn how to do that in a minute. I just didn't change my map. All right. Do we have this? Hey, focus, or we will have homework because we won't be able to get finished. Okay? Focus. Did anybody not get this picture? All right. Now you can tell your calculator to find your vertex for you, but the only time that you need to do this is when it's a decimal. Everybody good? Because otherwise you won't get credit unless you show me what? Work. All right, here we go. Do you see right next to the graph button how it says that button? Trace.
Yeah.
And right on top of that button, trace, it says in blue or in yellow, calc, which stands for calculate. Okay? So it stands for calculate. We're in math. All right? Now, is our graph a maximum or a minimum? Have you learned the trick that you don't have to scroll down and hit enter already?
Yes.
What do you have to do?
Press the button.
What button is it?
4.
It is on number 4, so you can just hit 4.
I didn't know that.
I taught you a new trick. Some of us learned it already, but. All right, now, what is the question that it's prompting you to do?
Well, hold up. We go to trace.
Second, trace,
Gotcha.
and then it's a maximum, so you go down to number 4.
Says the left
It says what, Abby?
bound. Left bound.
Left bound. Your calculator, look guys, do you see this this cursor that's flashing? Yours may be in a different spot than mine. It's okay. You need to get that. You need to get that cursor on the left side of your. What are we trying to find? No, we're trying to find our vertex. That was the very first thing it asked us to do in the problem. Okay, so we hit our left arrow button until it gets somewhere on the left side of the vertex. You want to be far enough away that you can easily see it is not on the vertex. Because if you put it on the vertex, it won't do it right. Doesn't matter how far to the left you do it, just somewhere on the left. Everybody good?
Is it never going to be a whole number?
If it is, then we won't need a calculator.
Okay.
Then we're going to do like we did yesterday. All right, and we hit enter. Your calculator's like, hey, I don't have enough information yet. Now what does it need?
Right down.
So now you've got to move your cursor on the right side of the vertex. Doesn't matter how far, just as long as it's somewhere on the right of that vertex, and hit enter. And your calculator's like, hey, do you want me to guess where the vertex is between these 2 points? And I'm like, yes, I want you to guess. So we need to hit enter one more time. And you may have different decimals than me. It is okay. You should get something along the line of negative 1.5 and something along the line of 6.25. Y'all okay?
1.4999999.
Like I said, yours may be rounding differently, but it's okay. All right. So we go back to our notes, and we now know our vertex is at negative 1.5, and what was it, 6.25? Okay.
6.25.
All right. Now, if your calculator, Sebastian, is negative 0.499999999 forever, just put 0.5. Okay? Now, if it gives you 3 or 4 decimals, Sebastian, put those 3 or 4 decimals. But if it's forever, then just round it, okay? All right, maximum or minimum?
It's a max.
So just circle or maximum. Let's just be lazy, okay? And then what is that value always?
All real numbers. Never mind.
It is your vertex, which is this crazy stuff.
Negative 1.5.
Mm-hmm.
6.25.
Not times, but
He said,
Comma.
yep, comma. Okay. All right. What about domain?
All real numbers.
Always. There you go.
that are.
And what about the range?
Negative infinity. 6.25. Yeah.
There you go. Y'all okay?
Why would it do that?
It does. I'm just not paying attention.
Your S-intercept.
I know, but I'm being
is
lazy.
1.
Plus, I accidentally didn't make that tray a minute earlier in another class, and it makes a horrendous noise when it hits the bottom of that. So, I just gotta use that hand. Yeah. All right, x-intercepts. The word intercept means what number? 0. It means 0. The word intercept means what number again? 0. Listen to my question. What number?
0.
0. Jesus. Alright, find your graph. It does mean where it hits the x-axis. So what numbers does it look like it hits?
1 and negative.
1 and negative 4. Now when we go to our table, what numbers better be with 1 and negative 4 for it to be an intercept?
0.
0. Do I have 0 with negative 4?
Yes, you do.
Do I have 0 with 1?
Yes, we do.
So we know for a fact that our intercepts are negative 4 and 1. You can write it just like that as long as you don't put what around the sides of it. Because that does not mean it's an x-intercept anymore. That means that it is an ordered pair. Okay? Yes, sir.
And then asking just for you. Oh, wait, you would have 2 because it's a parabola. It was like that.
Okay, so if anybody has ever watched Trig,
All right. Number 2. Here we go. Number 2. Okay. Second graph. How do we always do fractions? Hey, chill out.
Okay, sorry.
How do we do fractions? Parentheses. So where do we go first? Guys, focus. Where do we go? Y equals. We clear it out. And when you do fractions, you have to do parentheses around it. And then x squared. I don't know what the rest of it was. What was it? Minus 7/3. So make sure you use parentheses around the 7/3. Plus 9. Okay. And then let's hit graph. It's barely there. It's so little. All right. Now, what did you notice when you graphed this one? It's barely there, right? It is really there. You just can't see it. Now, what happens when I look out of a really, really, really tiny window? Can you see a lot? No. What happens when you look out of a really, really big window like in the cafeteria? You can see a lot, right? There's a window button on your calculator. Do you see it at the top?
Yes.
Okay, hit the window button. The window button is right here next to y equals stop. Y'all good? Yes, dear.
just do zoom out.
No, because I want you to learn this. You're welcome. Go back to window. I know, now you need to put it back to the default setting. That's why you stay with me. Alright, so here's what I want you to learn. You can change them to be specific things. Because I know that some of you have already learned the zoom button, but the zoom button has specific numbers that it will change your windows to, instead of changing just the thing that you need. Does that make sense to everybody? Okay, so sometimes it's very helpful to do zoom in and zoom out, but we are not there yet. Sometimes it is very helpful to learn all about the calculator so you can figure out what to do best, okay? What part of the graph could we not see all of? Top, bottom, left, or right?
The top right.
So if we're dealing with top of the graph, is that my x's or my y's? That's my y's. So we're going to go down here. And is that my lower y's for my y minimum or my upper y's for my y maximum? Upper y's, my maximum, right? So before any of you even ask, X, S, C, L stands for X scale. That's what your X is counting by. Y scale is what your Y is counting by. Don't mess with those right now, please. Okay? Especially if it's not your calculator. What do you want to change it to? If it's wrong, we'll just fix it. You want to do 20? Okay. If you did 30, you're just going to get a little bit bigger of a graph, okay? Notice that now we have a little bit more room at the top. Was it already like that? All right, so can you see a little bit more of it? All right, now what did it want us to find in our notes? Our y maximum to be 30. We want to find our vertex, right? Where do we go to find our vertex?
We go to trace.
Second calculate, not trace, second trace, okay? And this time, do we have a minimum or a maximum? So you can just hit the number 3, and it'll take you right there. My cursor already showed up on the left, so I'm just going to be lazy and leave it there and hit enter. If yours is not there, just move it over. Now we need the right side, so hit the right button until it is somewhere on the right side of that vertex. It doesn't have to be too far, just somewhere on the right, and hit enter. And your calculator's like, hey, you want me to guess where the vertex is between those 2 points? And you say yes. So enter. Now, your calculator may round that y to 7. It is perfectly okay if it does, because it's close enough. Are y'all okay? Yeah. All right. But I'm going to use this one because it gave me this one. So if it gives you these decimals, use these decimals. Just depends on how your calculator is programmed to round. So we go to our notes. And our vertex was at, I didn't even look at the x value. What was it?
1.725.
Okay. 25?
No, just 5.
1.75.
1.75. Okay, and then what was it? 6.958?
Yeah.
Yes.
Okay, yes ma'am.
Mine has like 4 decimals and it's got the E symbol and it has a negative subcapital.
Okay, hold on. It's 1.75.
That's what we said.
I thought, wait, y'all said 1.5.
No, that was about.
Okay, well that's what I heard. Because, blessing, that's all you can hear, everybody. It's going to come, trust me, you're going to need it in just a minute. All right, minimum or maximum?
Minimum.
Minimum, what's that value?
1.75.
There you go. Same as the vertex. There you go. All right, what about domain?
All the numbers.
What about range?
Infinity and 4.
No, 1.75.
Oh, y value.
Oh, just kidding. 6.9.
There you go. To where? There you go. Y'all okay? Because now, Karen, when we get to the x-intercepts, you wouldn't be able to see your x-intercepts unless you had your stuff set right. Okay. All right. So here we go. X-intercepts. Go to your graph. Where does it look like it hits the x-axis?
It doesn't.
It doesn't. Come up with 0, right?
Yes.
Yeah. It hits right there on 0.
Oh, wait, no. You say.
No, not possible.
We don't say no solution.
Not impossible.
It's asking us for x-intercepts.
No
Improbable.
X.
You're on the right track. Do we have any x-intercepts?
No X-intercept.
So we're just going to write, what's the shorter version?
NA.
None, right?
Okay.
None. We ain't got none.
NA.
Table, it says
Not applicable.
X has a 0.
NA.
The x is a 0 would be y-intercept.
I'm sorry.
All right.
I'm sorry.
Number 3, I want you to do something real quick. Go back to your table. You on your graph? Not to your table, excuse me. Go back to your window. I'm sorry. Go back to your window. I need to set it back to the default setting. What was the default setting? 10s and negative 10s. Your minimums are negative 10s, and your maximums are positive 10s. If you set your minimums at 10 and not negative 10, it will give you a window error, okay? So make sure they are back there, and then hit second quit. All right, I want you to try number 3. Back to window. And your maximum should be positive 10, and your minimum should be negative 10. Number 3, look, you do number 3, except for, listening, are you talking? X-intercepts. Do not do the x-intercepts. You do number 3, except for the x-intercepts. Do not do the x-intercepts. Did y'all just hear me?
Yes.
Okay. All right.
Yeah, you gonna sign there today?
I don't know. My one is, no, I'm going to Suzuki, so I already ordered it.
Jason, you get a shake at home.
Are you doing number 3?
I am. Look, I'll just put it.
Whoa. Do number 3.
2x squared minus 6x.
Hey, did you get that as a picture? What are you missing? The bottom of, which means it is my X's or my Y's when I go to my window. Y minimum. There you go. What do y'all want to change it to? Negative 20? Okay. You just need it big enough so that you can see your vertex, right? And you should have gotten that. And then second, calculate. It's not calculated here. What better? I didn't call you that. No.
What did you change it to?
Negative 20. All right, did y'all get about 1.5 and negative 13.5? Y'all get those? All right, sweet. What about your max or min? Which one? It's the minimum. What's that value? Same thing, 1.5 and negative 13.5, right? What about domain? There you go. What about range? Perfect. Bracket negative 13.5 to infinity with a parentheses. Now, what about the x-intercepts? Not yet.
There you go to graph.
Not, well, yes, we're there. Where are the x-intercepts? They look like negative 1 and 4, right?
Yes.
Which means now when we go to our table, what should we be looking for?
Zeros.
Zeros at negative 1. Ooh, what's with negative 1? Negative 1. It's not 0. So even though it looks like it's my x-intercept, do you see now why we have to check it? Because it's not really. It's really, 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 really close to negative 1, but it's not actually negative 1. What was the other one? 4?
4.
Does 4 have a 0?
Negative 1.
There you go. So it's really, really close to 4, but it's not actually 4, which means my x-intercepts are what kind of numbers? Decimals, which we will learn how to find on Monday, okay? On Monday. We are finished. We will finish doing that on Monday. It has an x-intercept. We are going to learn how to do that on Monday. I say that about Sebastian.